Good morning, students. Now we'll discuss about an important topic: Poissons and Laplace equations. Poissons and Laplace equations. These two equations are derived from Maxwell's equation. That is, we know that the Maxwell's first equation, that is the Maxwell equation for electrostatics. The Maxwell's first equation is del dot d bar is equal to rho v. Del dot d bar equal to rho v. Here we are substituting one simple formula at this position, at d bar. That is, we know that the relation between d bar and e bar is d bar equal to epsilon naught e bar. It is the relation between d bar and e bar. Now I am substituting this value here. I am substituting there. Then it will become del dot epsilon naught e bar is equal to rho v. Now I am again substituting one more substitution instead of e bar. That is, we know that the relation between E bar, electric field intensity E bar, and electric potential V is E bar equal to minus del V. It is the relation between E bar and V. Now I am substituting this minus del V here. So I am getting here del dot epsilon naught instead of this E bar minus del V equal to rho V. Here we are having del and del square and V epsilon naught equal to minus rho V. I am letting this minus to this side. Then del square V equal to minus rho V by epsilon naught. I am bringing this epsilon naught to this side. Here it is multiplicand. When it will be comes to this side, it will be divided. That is, it is called as Poisson's equation. Poisson's equation. Now coming to the Laplace equation. Laplace equation is also derived from this equation. That means the Laplace equation will be exist for charge free region. That means whenever there is no charge free region means no charge, then the value of rho v will becomes 0. No charge means rho v becomes 0. Rho v means volume charge will becomes 0. Then the above equation can be written as del square v is equal to 0. It is called as Laplace equation. Like this, we are having Poisson's equation and Laplace equation.